Are you guys alive? Looks like mostly alive. Our Zoom meeting is active if you want to jump in. It's on the announcements. Make sure it's on the announcements. So let's copy that. Go to the announcements for me, and let's select that Zoom URL, because I've got it set. It's a link, so you have to be careful to select it. Select it carefully. I'm going to open this announcement so I can select it easier. After you've got it selected, bless you, Control-C to copy it. Then go to your desktop. And they like sort of have us blocked from the desktop, so you can't do paste as shortcut. That would just be too easy. But what you can do is new. So click new shortcut and then paste that Zoom URL. I have some extra junk I'm going to get rid of. And it should just end with that phone number, that 417-447-8150. When you click next, this will be the shortcut name on your desktop. So I named mine Zoom meeting because, like they mentioned in the previous class, there's already a Zoom shortcut that takes you to Zoom. We want a new shortcut to take us straight to our Zoom meeting. So whatever you want to name that one, name it and then click finish, and you'll have a shortcut on your desktop to it. And you could do that wherever you want a shortcut if you want to save it someplace else. And I use Chrome, that's why mine has the Chrome icon. Yours might end up with a Firefox icon or something, depending on what you use as your default. I'll just keep one up there and have it. So I was looking at our stuff. And in week 6, we have these repl courses, and I was looking at them, and I think that we need to do a little bit with those, because I don't see any of you that have a lot of them done. And I don't want you to be in a bad spot. So I'm going to go follow this link all the way to find the links to the invitations. I think you guys are already in the course. I want to start on this 4-5 course, which is just extra practice in looping. So let's go to that one first. If you're not already in it, click on that invitation link. If you're already in it, you can just go straight to repl and bring it up. So we're going to have a lot of assignments in this one, 22, but they should go really, really fast once it gets there. They're just building off of each other. Is it really almost Friday? I knew it was this morning, but then I sort of lost and I started over a whole new week this afternoon. I was thinking it was only Tuesday today. Has it been terrible? I mean, I can't even tell you.
We're ready for it to be over. I'm so tired.
I know, it's just keeps going and going. We've had a hard one. It started out Monday morning. I was in the bathroom downstairs. We have this 2-story house now, which is a really big deal for us to buy. We shouldn't have. And I heard this ka-thud, ka-thud, ka-thud. And I thought, oh no, my husband fell about halfway down the stairs. And he said, oh, I got myself stopped. And I was like, uh-oh, how'd you get yourself stopped? And that's where he was hurt, of course, is the arm that he whammed into the wall to get himself stopped. And then I have a Volkswagen that's still in Carthage. in a storage building. It's probably worth $400, and we've probably spent $200 on storage so far for it, not counting other things. We can't tow it up here until it has tires, so we spent another $100 on tires. Ready to tow it up this weekend. Finally got everything ready. So my husband asked his father if he could borrow his truck, and he has one of those great big giant trucks with dualies on the back and stuff. So he was going to get it Friday, go get the Volkswagen Saturday, and be done. His dad called Monday and said, "Oh, I need you to come get the truck on Tuesday because we're going out of town." So on Tuesday night, my husband stopped, got the truck. He brought it to our house. He was backing up, and he hit like a bush, you know, that should have just given way. And instead, it broke the side mirror on the giant truck. So we're waiting to see how much that'll cost. So great week. We've all had a good week. Why are you so tired?
Just like it's been a week of tests and papers.
I said, you guys weren't supposed to have tests this week. This is supposed to be one of those weeks where you didn't have all that stuff.
Everything's due.
Everything's due every week.
I was supposed to have like the last round of tests like next week, but it got pushed back another week, so I'm really excited about that. Get a little more time.
That's nice. Now I'm looking down through at all of our assignments here. You can see what I see. I see that there's 3 people that are waiting for help on this one. And so these are the things, when I'm looking at repl, I don't get any notification about that you've submitted an assignment. So that's where I need you to send me an email so I can go look and help you. If you look up here at the top, you'll see how many notifications I got from repl in the last day and a half since I cleared it. So I'm sure not going to catch them if they were to give me a notification, which they don't. So be sure you email me if you need help, because otherwise you might be waiting like 2 or 3 days until I accidentally happen upon it. And then we don't want it to be that way. I want you to get help as soon as possible, which might not be that moment, but pretty quick. So let's look at 1-0-0, request input. I got to go a different way. Let me get in a different spot here. That's not how I want to do this. And hopefully everything looks good on this one. Okay, you guys give me some feedback here. Is this right? Is this one that you guys all need to do? You've done this one? Other people have done this one?
You aren't sharing your screen.
Do I?
You aren't sharing your screen.
Oh, thank you. So let me look and see what I'm looking at wrong, because if you guys are all done with it, I don't want to mess with it. We got lots of other stuff to do. Oh, thank you. Thank you, repl. Oh, yeah, you guys are in good shape on this one. What was I looking at? Maybe that other one. Is it the methods one we need to look at? So I'm going to click on this 5, Java. There's a method for that. So how about this one? Do you guys have it done? Jesse's done. Are you done, Jesse? Not done? Okay, good. So I'm going to do it. Not done? Not done? Not done? Not done? Okay. Because this one seems like, I think that there may have been changes that I didn't get saved or something. You know how that happens. So don't feel bad if you've got to tell me something is wrong. Bless you. I'll just be mad at you for a little while, but I'll know in the end it was my fault. So do tell me, because we want everything to be right. So what I found in this one last night was that I had added this little note about what page of the textbook this was on. And I don't remember, I don't know if I went back and forth and decided, no, everybody should already be looking at the textbook and know where this is, or if I just didn't save my changes. But it made it a lot harder to do without that reference. So we don't need to go look at that page in the textbook. I just wanted to let you know But I did change that last night, so if it's something you'd looked at already. Yes, sir?
I have a quick question. Are we supposed to still do all the ones in 4.5?
Yes.
All the time?
Yeah, and it's just practice. So you won't have any trouble. Those loop ones, shoo, you'll just be running through those in 5 seconds each. Let me know if you're not. The reason why, Perry, because I don't think really need to do them. And that's a thing, because the reason I made them an assignment is totally not this class at all. I'm getting a lot of emails from people in the online class that are worried that they're not understanding things. And when I go look, they haven't even enrolled in the repl, let alone tried to start going through it. So I would imagine that they're having trouble understanding things. If I look, they haven't watched any videos. They haven't, I would assume they probably haven't read their book either. And so that's why I made it an assignment. So if you guys have trouble doing it, I want you to send me an email and let me know. Like if you spent 5 hours on it, I don't want you spending that kind of time. You know about while loops and for loops, and these guys don't. She doesn't. Samantha's getting there. Yeah, it's not too bad. It shouldn't be too bad. You go through it like an editor and find errors and problems for me, and then you can send them to me. Say, you've got all this experience. So this first one that we're looking at in the methods section, we have a main here that's just prompting for input. So if we run it, we should see that it's already a running program. Let's try it. So right now, it prompts for a numeric integer, and it just prints it out. So it doesn't do a lot, but it is already working. So if we look at the code here for this program, we'll see we set up our scanner, we declare an integer, we write out a prompt, we set up a Boolean variable to be false, and then we go into a while loop that's dependent on that Boolean variable. As long as that Boolean variable is false, we're going to continue executing this while loop. Inside the while loop, we actually print that prompt. Sorry, I said we printed it earlier. We were just setting up a variable for that. In our while loop, we actually print out the prompt. And then we have this special scanner method being invoked. Has next int. And what that scanner method does is check to see if what's been typed on the console screen is an integer. If it is an integer, then we're going to follow this true path and we're going to read it. We're going to actually do our next int command to read it, and we're going to place it in the variable I for this particular code. We're going to update our Boolean variable to be true, so that'll make us fall out of that loop. We have a good integer. Everything is glorious and great. And after our while loop, we'll print out that integer. Now, if our if statement does not come back true, that means that whatever somebody typed on the console was not a valid integer. It could be letters or it could have a decimal place in it, but for some reason it's not an integer. So we're going to jump down to the else clause and print out this message, error, invalid integer, try again. Then after the if statement, no matter what, whether we got a true result or a false result, we're going to issue this command sc.nextLine. And that command discards any other junk that's still on the console input line. We'll continue executing our while loop then until we get valid data. So let's try running it again and putting in invalid data. We tried a good number the first time. If we try invalid data, we get a try again. And it doesn't matter how many times we put in something that's wrong. It'll just keep looping and prompting us again until we finally put in a valid integer. I'm going to try 32.2. Let's see what that does. Oh, see, it's still invalid because it had that decimal place in it. And we said we want to read an integer. An integer doesn't have a decimal place. Now I could put 34 and then a space and a word, that should work, right? Because it should see that integer and let us read it in and then discard the rest of what's on that line. And it did do that. So pretty cool code. These commands for the scanner are directly from our textbook. So there's some kind of unusual commands, but they're really handy. So this code is perfect for you for data validation. If you get in a spot where something in your assignment says, validate the input, this code here has got it for you. It's already doing it. So you might want to change it around a little bit. What if we wanted to read a double? We would use has next double, and then we would use next double to read that in. So we could still do the same thing. So awesome. It's all good. But the instructions here say we don't like it this way. We would like to create a method that does this prompting for input. Because methods, remember, each different subprogram that we create in our program should have its own logical function, its own logical purpose. Our main should be controlling the flow of the program. It shouldn't really be prompting for input. So we want to create a new method to do that prompting for input. Make sure I'm here as a student, right? I don't want to be messing something up. So the first thing I see is create a new method. Make sure the method is inside the class, because that can be one of the really hard things when we start out with Java or C# is all our curly braces. So I did add a comment here that we want our new method to go here. We want it to be after the closing curly brace of our main method, but before the closing curly brace of our class. So it can't be stuck in the main method because the main method's already a method, can't put another method in a method. We have to have our methods in our class. So what am I going to do? I'm going to be a cheater? Not really. I'm not a cheater. I'm a time saver. I'm going to copy this and paste it where it says to place that new method. Now I need to indent a little bit, clean things up. And we normally have our method header and curly braces indented, like one indentation level from the edge. If you notice, our class statement and its curly braces are usually at the leftmost edge. Then all of our method definitions and curly braces are indented one level in. Now I need to add some code into that method because that method header is beautiful, it's nice, but it's not going to do anything. So our instructions say move the code in lines 9 through 22 into the new method. So 22 is the end of the while statement. 9 is the declaration of our integer I. So I'm going to cut all of those lines of code and I'm going to paste them inside that new method getInt that we just created. Is our getInt method public or private? Private. Says it, doesn't it? It's also static. What kind of data type is it going to return to its caller? Integer. So it's returning an integer. Our method name is getInt. The parentheses are specifying the input that our getInt method requires. So we are creating this method, getInt. It has input and it has output. We already decided our output is going to be an integer. We don't know what it's going to be named or what variable we're going to use, but we know it's going to be an integer. Our input, we also know we need a scanner and we need a string. Within our parentheses, where we specify our input to the method, we have to say each input item, data type, and name. So our scanner is going to be called SC inside this method, and our string is going to be called prompt. We have to have commas in between all those different input data items that we need for our method. So let's see what our instructions say now. We did good. We moved all that code in there like it says. Now it said to update the code copied to the method as follows. First, delete the declaration for the string prompt. So we're going to delete this whole line. We don't need that string. The prompt that we're going to display is going to be passed to our method is an input parameter. That was our input string. So that's why we don't need that variable anymore. Second, we want to add a new line of code at the end of the method. So I'm going to go down and find my closing curly brace for my method. And I could comment that if I want. End of get int method. So in between the closing curly brace that ends our while and the closing curly brace that ends our get int method, we want to put this line of code, return I. And that's going to take care of generating our output. The integer now that we're going to be generating as output is going to be our I variable. Now everything looks good. We just need to call our new method. Let's run our program right now before we put that call in and see what happens. Not much. First of all, back in our main on line 10, we have an error because we moved our I variable down into our method. When we declare variables, they're local in scope. So that means our I variable is now only available within that get input method. It's not available in our main anymore because we moved it. So we're getting an error on that. So let's go ahead and update this line of code to be like the instructions say here at the end. So it gives us the whole system.out.println that we want. The integer is, and then instead of printing out I, we want to put in a call to our getInt method. Our getInt method needs a scanner, and our scanner here in our main is named SC, so we'll use it and pass it to our getInt method. We also need a string. We'll just type in this prompt right here in our call. Enter an integer. So now if you run it, it should look just like it did originally, which is what we want. We want to be able to enter an integer and have it display. And we also want to make sure that our error still comes out if we type in something invalid. So it looks good. Everybody's working okay? Working? Okay, so we created a method. Let's copy this code. I want to Control A and Control C, and I want to go to that website where we can visualize the execution of our code. Because when we looked at that website before, we didn't have much going on in our code. Now we are calling a method, so we should have a little bit more to watch. If you remember, I just typed visualize code to find that site. I could set up a shortcut or something for that too, huh? Now I'm going to paste my code into the visualizer, but I need to change my code type. I should have done that first. I'll change it to Java 8. Oh, yay, it didn't erase at all. Now they've added a new option. Oh, shoot, it's only for Python. Never mind. We want to click this Visualize Execution button. I got to make my class public. This visualizer thing likes a public class. It's thinking about it. There we go. It's very happy with itself for helping me solve that public problem. I'll just close it. I'm not going to congratulate it for that hard work. Now, our red line is at our allocation of our scanner. If you click forward, you should see that line of code get executed. And there is our scanner named SC. And if you notice, it's pointing at the Java scanner. So that's our instance. So that one line of code set up our scanner. Now if we click forward again, we're going to be running our output statement to print out that message. So we start out with our get, enter an integer, but notice as soon as it printed out our get, the integer is, or enter an integer, it ran into our call for our get int method. So you can't see it very well, but my red arrow is actually pointing at the beginning of our get int method. Let me make this not full screen so we can see it a little better. So, get it here. There we go. I'm ready now to continue executing, but my execution path has been altered and I'm now in the get int method. So as I click on forward, we should see the code within our method get executed. So first, our I variable will get declared and set to a value of 0. Next, our isValid Boolean will get declared and set to a value of false. We'll go into our while loop, and we can tell that our condition was true because it's now executing the body of our while loop. And we're going to do the print of our prompt. If I look up a little bit, you'll see our print output that was printed out, enter an integer. Now we'll see if our visualizer is going to be able to handle this has next int method. Nah, it just went straight to our error. And then it's going to clear out the line and get mad at us because it doesn't like that code from our textbook. So we'll have to talk to those visualizer people. But I hope you could see how it's moving down into that method and executing the code that's in the method. We've got a great debugging chapter coming up that'll help us with all of those things. Visualizer failing on me. All right, so this one's done. So let's fix up our comments. So your developer, the developer is you. Put your date here. And your purpose. And I'll just say we created an input method. Now let's look at things a little bit. First of all, our main went from all of that code to just 2 lines of code. Notice how easy our main method is now. It's very simple. We simplified it by creating that new method. So we, again, even though a method might be a little complicated at first, in the end it helps us to simplify our code. Our get input, it might be doing a little too much, but we'll check. So you should be able to submit that. So let's look at our next one. In this one, the code that we have started out with, the starting code, is what we just completed in that first exercise. So it was copied to this exercise as a starting point. So we see our main just has the two main lines of code, and then it has our getInt method. Our requirements or instructions say, update the supplied code to create a method, blah, 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 that prompts for and validates a numeric integer within a range. So right now, we're just validating our input is valid. We want to validate it is within a range, like between 10 and 20, or whatever the valid range is. You know, it could be 0 and 100, or 5 and 6. But we often have to validate data to make sure that it's within an allowed range. So we're going to create a new method to do that. We could run the code that we have because we want to make sure it works. Again, it should be basically the code that we just got done with in our last program. Does the same thing. Looks good. So now we need to create a new method. And this method, again, has the name that matches the code in the book. That's why it's named that way. But I want to add this new method definition after the getInt method, closing curly brace, but before the closing curly brace of my main. So again, I'm going to copy this method header and paste it. So looking at our method, our input has changed. Now, besides a scanner and a string, notice it's on the next line, we are saying we also need 2 integers as input into this new method that we're going to create, and it is getInt within range. So if I look at my method header, it's still private, it's still static, and it's going to return an integer, just like the previous method. But it has a new name, and it requires more input. So our instructions are declare an integer and initialize it to 0. All right? What do you want to call it? I'll call it variable. Declare a Boolean valid switch and initialize it to false. Boolean is valid equal false. Now, step 4. It says, within the while loop, call the getInt method to return a valid integer. Oh, I got to do step 3 first. Create a while loop that executes while the Boolean switch is false. So I can say while is valid. How can I make that false?
Exclamation point.
Exclamation point. So as long as our is valid Boolean is false, we'll execute our loop. Now I can do step 4. Within the while loop, call the getInt method to return a valid integer as follows. Now I'm going to use my variable because I don't have a variable named I. So it looks like I'm going to be moving the call to getInt from my main method into this new getInt within range method. Now, after I call getInt and we have an integer to look at, we want this if statement structure. to validate that we're within the required range. So this is going to be within our while statement. If our variable is less than or equal to our minimum, which was passed to us as input, remember. We're going to print out a message. Error, exclamation point. Number must be greater than, and then we're going to use concatenation to output the rest of our message. We want our minimum value plus a period. So now I've got this if statement. If the input variable that our user just typed is less than or equal to our minimum that we were passed, we've got a problem. The number's too low. We need to have a bigger number. Now, if that's not true, we're going to check another condition. If our variable is greater than or equal to that maximum value, again, we want to output an error message. Error, exclamation point. Number must be less than and then we're going to concatenate our maximum and concatenate a period. So now in our method, we are taking care of asking for an integer, and then we're checking, is it less than our minimum? Is it more than our maximum? In our last condition, we're going to say, well, if it's not either of those, it must be within our range. So we're going to set our isValid variable to true, that we got a valid number. I'll label some of these. Here's the end of our if structure. And the end of our while. And finally, my closing curly brace had unindented. Here's the end of our method. The reason I wanted to do that is because our next instruction says, after the while statement, return the value of the now validated I, which ours is called variable. So our new method is complete. We used the input that was passed to us, and we're returning the final valid number to our user. Now, we still aren't calling it yet, so we've got to go back to our main. And the last instruction says, update the print line statement in the main to call the new method and output the return value. So let's see how we're going to change that. Instead of calling getInt, we're going to call getInt within range, our new method. We want to pass our scanner, and we want to pass our prompt, enter an integer. But then after that, we need another number, and this is going to be our minimum. I'll go ahead and make mine 5, and I'm going to make my maximum 25. So we're saying the valid range is going to be between 5 and 25. So we just really easily added more input to that method. Now we should be able to run it. So let's see, I'm going to start with the top error. because the top error could probably be related to a lot of the other errors. It says I've got a problem on line 11. You guys probably don't. But in line 11, it says I'm missing a closing parenthesis. Oh, it's not true. What my problem is I should have a comma here, and I accidentally have a period. So that's why I was confused about my parentheses. So that probably will take care of a lot of those error messages. I'm going to check. Very good. Okay, so I want to try a good number. Oops, too big. What if I do letters? Does it catch those still? Oh, yep, invalid. What if I do too small? Oh, it wasn't too small. I tricked myself. Let me try again. I said my smallest could be 5, so I'll try like 2. So my must be greater than message is coming out too. So everything looks really good. How about yours? Is it working? What you got?
I must have missed something because it just keeps asking me for an integer. So it just keeps asking. It's like, if I do it's valid, like 15, just asks again. I don't know.
Yeah, you don't have our else box. So, right here. Not huge. Does it match? Looks like it matches. Submit it. So again, in this section 5, this 5th Java REPL, there's going to be some really good sample code for you guys that you'll probably want to refer back to. Now, the next one says we're going to clone a method. Let's take a look at it. This one wants us to take all of our getInt stuff and update it to, well, actually copy it and create new methods to recheck for valid doubles or decimal data. We also want to validate a double within a range. I want to have my code to start with, though, that already has the getInt within range. So I'm going to go back to that previous REPL and copy that code. Maybe. And now I should have everything that I need to clone. It's kind of making me do too much work before. So the first thing we want to do is review and run our supplied code. You can run it, make sure your copy was good, that we didn't miss anything. It's easy sometimes to miss a closing curly brace. And looks okay, it still seems to be working right. Now I want to create a new method. I want to use getInt as a base or as a model. And I want my new method to be getDouble. So let's find our getInt method. And I've got the end of it right here, the closing curly brace. I'm going to select all the way up to the beginning of that method and copy And then I'm just going to paste it right below. And I'm going to change my comment here to say end of get double method. Okay, we want to update all the int references to use a double data type. The first and most important one is the one that's in our method header. Up here where it says int, we want to make sure that we change that to double. That's going to be our return type. Then my I variable needs to be a double. In my while loop, in the if statement, instead of has next int, I need to do has next double. And then to read it in, instead of next int, I want to do next double. I think I'll even change my error message. Instead of saying invalid integer, let's say invalid double. Not very helpful to a user, but we'll try it. We shouldn't need to impact the get line or next line statement. We're still going to return I, but I do need to change the name of this method. So from get int, I want to change it to get double. Now using NetBeans, we have nice edit and replace options. So we could have selected that code and done some sort of change all. But when we're first starting out, I kind of like to do all of the changes manually because it's real easy to miss one, and then it'll kind of point that out to us. All right, so we've got our get double method created. Now we want to create a new method, and we're going to use our get int within range as a model and make the new method get double within range. So I'm going to find the end of my get int within range method, maybe. And I'm going to try to select all that to copy it. I'll put my new one after this one. And I'll start making some changes again. Starting at my method header, my method declaration, instead of an integer, I want a double. My method name, instead of get int within range, I want it to be get double. What about our input parameters? Do we want our minimum and our maximum to become doubles now too? Might as well. My variable needs to be a double. Anyplace else? Looks like that might have taken care of us there on this one, huh? Because the rest of our code is checking against that minimum and maximum.
What about the variable equals get int?
Where,
The
there
while
we
is that
do. Yep, we better fix that one. Because we want to call our new get double method, not our old get int method. The last change that we need to make is to update our print line statement. And we could just copy it. Let's copy it and we'll get both of them going. I'm going to go all the way back up to the top to our main. And I'm going to copy the print statement, the print line. Now, I'm going to make it say the double is, and I'm going to make it call get double within range. Do I need to change anything in the parameters? I should probably make my prompt say enter a double. What about my numbers? Are those okay like that? You want to try and see if it cares? Yes, sir.
In your instructions, I think there's a mistype because it says update the print line statement and there's an extra E after print line.
Yep, I see that. Luckily, you guys are awesome programmers and can handle that. So let's try it. Enter a double. My number is too big. And it took it just fine. Everything looks good. Everybody's okay? What's the matter? I think that's what it says. Those red ones are hard for me to read. Yeah, it's just. That's what it's doing.
Is SC. Yeah. So is yours the same? Is yours? It's on 38. Instead of the I. Oh, the two, to the parentheses after that, yeah, the two parentheses.
Oh, oh, you're just going to copy the whole lesson. No, that's your class. So we want to get to here. So what?
The first section they know.
No, we just copied this get rid of this. Yep. And that's what we made into our get double.
Two errors.
So what do we need to finish this one up? Is our output the correct format? Or do we need to get rid of something or change something? Can we check? Oh, mine matched. Yay. If yours doesn't match, just go ahead and submit it and we'll fix it up here in a little while. So that leaves us like, let's see, you have your palindrome. Let's look at this next one, but I don't know if we're going to do it because I want to make sure we get onto our other stuff. So in this next one, create check even method. Oh, we should be able to handle this pretty easy. Says update the supplied code to create a method that prompts for and validates a numeric integer. So if we look at the code that we have here, it's not perfect, right? It does the getInt method, which it looks like it's missing, all sorts of great stuff. So what this thing wants us to do is create an isEven method that returns a Boolean. And we just want to know if the number the user enters is even or not. So I see there's a problem though, because I don't see a getInt method. I'm going to try to run this thing and make sure, oh yeah, it's just really angry. So again, I'm going to go to the previous assignment and copy my getInt method. Like I said, this is something that I probably am going to want to use a lot. So I want to go from the method header that declares our getInt method all the way down to the closing curly brace that ends that method. And I'm going to copy that. Now I like making you copy and paste things because it's making you really find the beginning and end of these methods. In some cases, it might be better to make you type them all out, but sometimes people just type things and don't really even notice what they're doing. Where when we have to get the exact right lines, we're for sure getting the beginning to the end so that we can get clearer on where these things start and end. But I'm going to paste this now after my main method. Because I remember I've got to have this code within my class, but not within that main method. Now if I run it, it should run. Let's make sure. Oop, I got some, oh, my isEven is not in here yet. So the code is already in for that. So I need to add it. If I look up here, it is already there. So we're supposed to create an isEven method that returns a Boolean. And we're actually in this using a ternary if to make the method with one line of code in the method body. We have a ternary if up here in our main as an example. So what's a ternary if? It has three things. That's why it's ternary. The first thing is a condition. So in this ternary if, our condition is enclosed by parentheses, and our condition is even the integer. That means calling is even and passing it the integer is input. Does the result come back as true? If the result comes back as true, I'm going to do this code after the question mark. If the result of this comparison is false, we're going to execute the code after the colon. So those are special characters that are required by this ternary if. So a ternary if, notice there's no word if, we just have the condition part enclosed in parentheses, then question mark, true path, colon, false path. So it's a pretty interesting piece of code here for Java. Let's add in our isEven method. I'm going to put it right after the main method. I'm going to start out with that private keyword. Do I need static? We need static in anything that's going to be called by our main method because our main method is static. So I will say this one is static. We said this needs to return a Boolean, and we're going to call it isEven. Our isEven method needs our number, so I'm going to say our inEven method requires input of an integer, and I'm going to call that number within my method. Now we can do this a lot of ways. If you remember last class, we set up a method like this and we just had the actual comparison and we said return, whatever the result of this comparison is, and we only needed one line of code. These instructions say to use one line of code, but to use that ternary if. So let's think about if we could do this. Let's start with return. Then we want to know if our number is even. How can we tell if our number is even? Modulus 2 equal 0. So we could really stop right there because that's going to result in either true or false. But we want to implement this ternary thing. So let's put our question mark and we'll say true, and then the colon, and we'll say false. Let's see if that works. Okay, now it's asking me for an integer. I'll try 5. The integer 5 is odd. That's true. Try to run it again. 12. Integer 12 is even. That's true. So we were able to use that getInt method that we'd created already and just adapt it to this new program where we were going to specify if our input is even or odd. So pretty easy for us to be able to take this code and make changes and try different things with it. Is everybody's working okay? I'm going to try to submit it. I'll be right there, sir. Looks good. Now the last one in this repl is from your book directly. So I will let you get that one done. What you got? Yes. It wasn't there. Yeah, we just
That's all.
All right. Our new stuff that we're starting with, kind of late, is talking about objects. When we're working with Java, one of the reasons that Java is popular, that it gained popularity, is because it's an object-oriented programming language. C# is also an object-oriented programming language, and there are lots of others. But object-oriented programming languages let us work with pieces of data and their actions as objects, so that we can create a class that has all of the information for an object that we need. So I have this little Unity app here. Are you going to run? There it goes, kind of slow. And let me make that big here. That's better. So each of these balls that this emitter is emitting are objects, right? Each of them is a separate object. Each of them is a separate ball object, right? Or sphere. So tell me some things about these objects. What kind of characteristics or properties do these sphere objects have?
Random color and trajectory.
They have color. What was the other one you said?
Trajectory.
Yep. Anything else?
Some size.
Weight,
Do what?
size.
Size? These ones are all the same size, but we could change sizes if we wanted to. That could be something.
Or physics different on some of them.
The physics could be different. So do we want to say physics, or would we want to say, I don't know, like speed, propulsion? I'll just put physics. That's fine. So all of these things, you're absolutely right, are characteristics or properties of each of these objects. So if I were to stop and say, what about this specific sphere? I could look at the properties of that sphere, and I could see what color it is, what its speed is, what its trajectory is, all those kinds of different things. I could even check to see if it's had a collision. I could say that is a property, that it has collided with one of the other spheres and made it go off sideways, different things like that. So each of those things are different properties that could be associated with every single one of those sphere objects. Now, each of those spheres also has some actions that it can take, some movement that it can do. So those would be our methods. What kind of actions do we have? We don't have a lot in this one, do we?
Falling.
Falling, for sure.
Rolling. Bouncing.
And with Unity, all of these things are going to be handled with some sort of, physics response type engine. But we can also see everything happening with them. One thing that each of these spheres has in common is an action that we want to think about is its instantiation. That's my big word for today. Instantiation means coming into being, right? Becoming a sphere that we could see, an object. So instantiation is like the birth of one of our objects. That's when that object becomes alive and starts doing things and working. So we really like looking at these spheres in this sphere emitter because we can really visualize how each of these are a different object. They each have different properties or characteristics, and they each have different capabilities that they can do. So great stuff. Turn it off before it breaks my machine. Sure, save it. Don't save it, whatever. So we have to worry about objects. Now, when we're working with object-oriented programming languages, these objects are things that we're going to work with in our programs. We're going to create all of the characteristics of these objects. Whatever we want that we decide is an important characteristic, we're going to create that as a data item for our object. And you get this here. I've got a USB port hiding. We're going to define all of that within a class. So far we've been looking at classes. We've seen REPL was really picky. It wants our class to be named main with an uppercase M. We don't have any options. All of the examples in our textbook show us with class names of something different. So we've seen that the class name can be like really important or not important at all, and that's true. REPL has made it really important because they just like looking for that main class with the uppercase M. We also have seen in NetBeans that if we associate our class with a package, then we have to be concerned about that too. Now that's a little bit separate. But we've been working with classes all along. We've just been kind of ignoring that and keeping those curly braces around all of our other code. So whenever we're working with objects, like our sphere, an object is just simply a variable that has a named location in memory, but it holds some supply data values, some different things depending on how we've created that object. So let's think if we had a person object. Each of you is a person object, right? Each of you has come into being. Each of you has properties and characteristics that others share, but your values might be completely different. So let's think about a person's name. That's a variable. Here we have a variable named person name that's been allocated in memory. We have Sam. Now, an object is just like that, just like a variable. But instead of holding one value, like just one variable, an object can actually contain many data elements. It can also contain all sorts of different methods as actions. And methods apply to this object, just like we saw with our sphere. So I could have a person name, Sam. I could keep track of Sam's favorite color and say it's green. I could keep track of a secret about Sam, some sort of sensitive information in my class if I wanted to. I might have an action or a method that was get favorite color. Maybe I want to ask him what his favorite color is in that method. So that could be an action in my class. That method would probably return that favorite color. Now, all of these data items and actions can be combined together to create a person object. So we would have a class. So whenever we create a class, we name our class the name of our object. So if I'm declaring a class that defines people, I could name my class person. If I were defining a class that talked about animals, I could name my class animal. So I can name my class whatever I want as long as I follow the rules of variable naming. Now, is a class name supposed to start with an uppercase or a lowercase letter? Looking at this one. Huh? Uppercase. And that's always true in Java and in the other object-oriented languages that I've seen. We always have an object start with an uppercase letter. After our class declaration, we have our opening curly brace for our class, and then we start declaring the variables that are going to be our class fields, our class data. Class fields that we define within a class are only accessible to that class. But we can have a lot of methods and things in that class. The class fields can be instance variables, which means Sam has one set of these variables, David has another set, Joanne has another set. I could have 57 people all in memory, and they would each have their own set of all those variables and properties because they each have different values for those properties. That's an instance method. When I want to create an instance of a person or instantiate the object, I'm going to use a special type of method called a constructor. My constructor always has to be public so that other classes can create instances of these type of objects. Whenever this special constructor method is executed, it allocates memory for the instance of our class. This one here doesn't take any parameters, no input. That's called a no-arg constructor. It has no arguments or parameters. Java will generate one of those for us, a default no-arg constructor, if we don't put that code in ourselves. It will do it for us, but we want to do it. Then the end of our class is going to be indicated with the closing curly brace. So we've got this person class we just created. Notice this person doesn't carry a lot of data, just their favorite color. Right? So not much going on there, but we can still look at them as a class. If we want to create an instance of our person or instantiate that person, like in Unity where we saw the spheres come out of the emitter when they were being instantiated, we have to use a special syntax. You've used it already for your scanner, right? So just like we say scanner name equals new scanner object, we use the same exact syntax. And we say, my class, person, I would like to create one of those, and I'm going to call it my person, and it's going to be a new instance of our person object. So look at the different colors there. First of all, the kind of orangey things are our class name. We see our person class name in that statement twice. It is duplicated. Then we have the reference variable. In this case, it's my person, and that just means that's what we're calling this instance of our person class. So this my person might have information about Isaiah in it, but it's called my person. And inside those data variables, we're going to see all the information about Isaiah. Now, one other thing that's really important is anytime we're working with classes in object-oriented programming, this new keyword becomes really critical. And the new keyword is what says instantiate an instance of this object. Make a new one. So now we're going to have our my person sitting out there in memory, and it's going to have that data field of the favorite color with some sort of value. Our favorite color right now is just null. It's got nothing. Because when in our constructor, we don't have anything to take care of this favorite color. We didn't get any data passed to us. We had no arguments. So our favorite color is just empty. Now, whenever we're working with our objects in our classes, we're working with encapsulation. And encapsulation is an important concept in object-oriented programming. Have any of you ever sent a letter via snail mail? Have you ever? Have you? I know a lot of people haven't. Have you ever sent a card or anything, snail mail? Seen it happen. Don't have to very often anymore. But what I do when I take a letter and I put it in the mailbox, I'm going to take that letter and put it in the envelope. That's encapsulating that letter within the envelope. When I close the envelope, then I'm going to put the address information and everything on there so it's ready to be sent, but it's encapsulated. Nobody looking at my envelope can know what's exactly inside there. That's why it's kind of like this giant iceberg. The part that we can see. It's public. We know it's out there. The rest of this thing is encapsulated or hidden, so we are not able to see it. Our letter, in the same way, is hidden within that envelope. We can't see it unless we open it up and take a look at it. That's one benefit that a class gives us, is I can set things in my class to be hidden so that other users, other classes can't see them. By encapsulating the data, I get a lot of benefits from object-oriented programming. It's hard for us to see them all right at first, but as we use more and get more experience, then we start understanding a little bit more about how this benefits us. Okay, so I've got my person class. I want to be able to accept information about this person's favorite color. Right now we said our default constructor, our constructor there, doesn't expect any parameters. So nobody can pass that information into me about this object's favorite color. So I need to create a method. My method is going to set the favorite color to whatever new color is passed to it. We're going to call this method setFavColor, and that's important because this method in Java is called a mutator. It's a mutator because it updates or mutates or changes the value of the favorite color in the class. So kind of another big word for today. But it's just like, why are Teenage Mutant Ninja Turtles mutants? Because they changed, right? Because they started out as normal turtles and then they mutated into Ninja Turtles. And that's what we do here. Anytime we use a mutator in Java, we're just updating this value, changing the value. So we can do that for every variable that we have in our class. So for our Unity spheres, I could have a set color, set trajectory, set size, set physics, set had collision if I wanted to, and then I could use those methods to change these values, to alter the way that sphere was working or performing. Now, whenever we're using a mutator object like that, the Java standard is that we use the word set, and then we follow it with the field name in the class that we're allowing to be changed. So here's our code that we would see. We would have code to create a person object, and then we could have a line of code that said, using our reference variable, my person, call the setFavoriteColor method and pass in the color brown so that our favorite color can be updated to brown. Now we have our myPerson object with their favorite color, and we're going to set that to brown through that mutator. Yay. Along the same lines, outside of our class, we might need to access that favorite color. Maybe we want to make a list of everybody's name and favorite color. To do that in our class, we would create an accessor or a getter method. So our method name is going to be named get, and then our variable name, and all this method is going to do is return our variable. It's that simple. But we have to call it from someplace else, so it gets a little bit confusing. So here is all of our code now for our person object. First, we create a person, and our person object is named myPerson. Then we use our myPerson instance to set their favorite color to brown. Then we set up a string called theColor, and we use it to hold the returned value of our person's getFavoriteColor result. So here we set their color to brown. In this line of code, we're going to get that color and end up with brown in our string. So we can update our person object. Now, what if sometimes people are going to send us the favorite color? We can have two constructors in our code, and this is called overloading. So if I use a statement to instantiate a person object and I don't pass any parameters, Java is going to use this constructor right here. If I use code to instantiate a person object and I pass in a string, Java is going to run this method here. Notice they're named exactly the same. That's called overloading. How do we know which one to run? We know which one to run because the parameters are different. And based on that difference, the Java runtime system will decide which one to actually run. So I couldn't have another one that had a string as a parameter, because then it would duplicate the one that we have here. But right now, those two are different from each other, because one constructor doesn't have any parameters, the other constructor does. That's overloading. Now in this overloaded constructor, we're going to accept that parameter value and use it to set up this person's favorite color. So now when we create a new person, instead of leaving our data inside our parentheses empty, we could pass in their favorite color. So this my person likes blue. So when we overload, we really are saying we could have multiple methods with the same exact name, but they have different method signatures. That means either their return data type or their parameters are different from each other. When we make a call then to one of those methods, that call will be deconstructed. The runtime will say, which one of these methods matches this call? Let's use it. And this gives us a lot of control and a lot of capability in object-oriented programming, because we can create the same method 5 different times and allow our users to have a lot of flexibility, but we don't have to have a lot of duplicate code. Okay, so here's our person that's more complete. In this person class, we say there's a private string that's the person's name, there's a private string that's their favorite color, and a private string that's their secret. We have 2 constructors. Our default no-arg constructor that just leaves all of those data fields empty. We just have this person out here in memory that knows nothing, forgotten everything. Or we could create a person passing in the name, favorite color, and their secret all at the same time. When that happens, we would set the person name for this instance of our person equal to the person name that was passed to us. We would set the favorite color for this instance of our person to the favorite color that was passed to us. And finally, with our secret, we would do the same thing. Now, as far as allowing people to access our data, we're going to let them set the person's name using a new name and get the person's name. So here we are going to create a couple people. Our first object is going to be named my person. This is going to hold information about Sam. Sam likes the color green, and he has some sensitive data in his secret field. We're going to set up another object, another person object, and this person object is going to be a variable named Jerry. The person's name, however, for this object is Kyle. His favorite color is purple, and we have some credit card information stored in his secret data. Notice we don't want that secret data going out to anybody that's unauthorized. So here's our Sam in memory and Jerry in memory. They're both separate objects that are out there in memory for us to use and move around and do whatever we want to with. So just like a big variable. Now, when we're working with classes, we need some way to document what's going to be within our class. We can get some pretty large involved classes, and there could be a lot of methods and a lot of different variables in our class. So we use this modeling standard called UML, the Unified Modeling Language. and there are some different rules for it. People are kind of flexible with it, but in the end, we use UML to diagram our classes, and we end up with the square, the rectangles for each of our objects. Here's a better one. This is an actual UML model that's complete for our student. So in our student object, in the UML diagram, we're going to start up at the top with the name of our class, student. Then we'll have a separator. After our separator, we're going to have some variables, attributes. This student is a little different than our person. For this student, they're keeping track of their name, their number on some sort of roll thing. We don't know what that is, but the people using it do. And then the section that they're in. Now, we notice that before each of these variable names, we have a special character. The plus sign indicates that our name variable is public. We'll let anybody access that. Our role variable is protected, which means that only classes within our same project can access it. And then our section number is private, which means only things within this class can access it. So our access level can be identified in the UML diagram by using those special characters that prefix all of our names. Then after all of our variable fields are defined, our class fields, we're going to have another separator, and we have all of our methods or operations or actions associated with the class. And again, the plus, minus, and hashtag thing are all the same, public, protected, and private. Down at the very bottom then, they have some extra component. It says this is not mandatory. Well, you can imagine, since it's not mandatory, nobody ever includes it, right? So you don't ever see anything past all of the operations that we have. So for our person here, all of our variables right now are private. We had name, color, and secret, but then we created some mutators and some accessors that are public. So we're going to let people get to these values, just not directly using those field names. They have to use our methods to get to that data. So that should be a complete UML diagram for our person object. So we can use that UML diagram to talk to people about what our class needs to do, to document for ourselves what all our class needs to do, and just to communicate with others. So it's really good documentation. You'll see them around. Now, to create a UML diagram, there are lots of options. You guys can use Visio, that free software you can get from the Microsoft Imagine account. It does diagramming. And if you look at the templates, they have UML diagrams as one of their defaults. There are some cloud-based tools you can use, like Creately, and some other diagramming tools that will let you create UML diagrams. And we can actually kind of create them using NetBeans. I've seen people also use Word, give themselves a very hard time to create them, but you can. So any of those kind of options are available to create a UML diagram. So lots of new stuff to learn, never boring. So this is how we're going to keep practicing on the stuff that we've done so far, but continue to be learning new things. Because as we implement classes, we'll be able to add some code, to do some looping, or to do some if statements, and to do some methods. So we'll get a lot more practice as we go. Questions? I'm going to open NetBeans and look at one of those projects that we created last time. Like my palindrome. If I open my palindrome and I'm looking at my main class, over here on the side, I have this navigator window open. Again, it doesn't show very good. It's kind of cut off because of the projector. You see that better? Notice how that sort of looks like a UML diagram, and that is exactly what NetBeans is doing to document this information, to show it to us over here in this navigator window. So it's saying you have a main class that's my class name up at the top. You have a method called getInput that wants a scanner. You have a method called isPalindrome that wants an input of a number and returns a Boolean. They kind of left that out of that one we were looking at. You have a main method, and you have a reverse method that wants input as a number and output of an integer. So NetBeans will kind of show us that UML diagram to keep us on track, see what's going on with our class, with our method, with all of those great things. Questions? You got it all. I'm so glad. So in the instructor videos for week 6, first is the walkthrough of the presentation that we just looked at. You probably don't want to do that again, but you can to see if I fumble in the same places. Now, the second video is kind of taking that information from that presentation and implementing it as a class. But the third video, this is the one you guys want. What's it doing? It's a walkthrough of your My Integer assignment that's due next week. So this one is a complete walkthrough of that assignment, talking about the different methods that you need to create and all the different things that you need to do. Yeah, so we don't have time to do it outside of the video, but we have time to have it in the video. Okay, got it. So yeah, that one should walk you through creating your My Integer. As you can tell, I'm going to use NetBeans and then copy it into repl. So make sure that you go through that one. This My Integer application, to me, is one of the hardest ones that we do all semester. So that's why you have a video walkthrough for it, because it's the object that they want us to create is just an integer. So it doesn't really have a lot of meaning. And then they want us to do a bunch of overloading. So there's several methods in here that are named the same. You know, one accepts no parameters. One accepts an integer as a parameter. And so it gets kind of interesting. So do write down questions, make notes about things as you're going through it, since you're going to have a little bit more time because you can pause it and stop. Write down areas that are super confusing to you so that we can talk about those next week, because those areas that are super confusing to you are probably going to be super confusing to other people. And what I'd like to do is for you guys to just kind of talk it out, because a lot of times if one student has a question, another student had that question and figured something out, it can explain it in a way that's going to be more meaningful. Because I'm like, I can't think of any other way to explain it. And so you guys do better at that. Okay, so try to get it done. I know it's not due until after we have class again next time, so you may not have it done before then, but I would like to talk about questions and stuff for it. So I don't think that we need to change any due dates then, based on everything. I think you guys should be able to get that one done without any problem. I don't want it to take up too much of your weekend. Questions? Yes, sir?
It's the last assignment. I forgot. I mean, I submitted in class, but I forgot to give Microsoft submit like the
Oh, go ahead and do it.
So I just see if that was
It's okay. Yeah, as long as it'll let you. Let me know if it won't let you. But yeah, that's fine. Okay, great. This one will definitely challenge you, so do not be surprised. Just remember, you've got it. You don't have to worry about it.